Chen begins where millions of workdays now begin, a blank chat box and a question. She asks for a launch plan. The answer arrives in seconds, organized, useful, familiar. If you stop the story here, ChatGPT would still look like a very capable conversational tool. But Maya notices a door behind the answer. Then another. The wall folds away. Behind the chat sits a document studio, a coding floor, a room of long-running tasks, an archive, a connector switchboard, a browser, and one last chamber full of locks. You thought this was a chatbot. Look behind the box. Ari Vega, the night shift systems guide, meets Maya in the corridor. He does not call the building intelligent. He calls it layered. One layer receives intent. Another produces files. Another changes software. Some layers remember. Some connect to external services. Some can operate a browser or desktop. Some can keep working after the first reply. And beneath every action sits a control layer. What tools exist, what data is reachable, what the agent may change, and where a person must approve. That stack is why the product increasingly feels less like one app and more like an operating system for work. The phrase needs a warning label. ChatGPT is not literally replacing Windows, macOS, or Linux. It is not one universal autonomous mode. The official product map spans ChatGPT Work, Codex, goals, scheduled tasks, memory, skills, plugins, browser, and computer use. Those pieces do not appear identically on every plan or platform. Some require a workspace administrator. Some depend on region or rollout. Some run locally, others run in the cloud. So this film is not claiming that everyone has the same superagent. It is asking what happens when the layers begin to operate as one system. Maya is a product operations lead with a launch on Friday, a scattered evidence trail, and no patience for a feature tour. She needs outcomes. Ari is our fictional guide through the machinery. He carries a ring of permission keys, but no master key. Their wardrobe never changes. Maya's rust-field jacket, amber glasses, and teal shirt. Ari's navy utility coat, cream turtleneck, and cyan seams. Consistency matters because this is a human story. The question is not how many buttons OpenAI can add. It is how a person moves from intention to an artifact, an action, and a decision they can defend. The first room is the one Maya recognizes. Official OpenAI guidance describes chat as the place to ask questions, understand a topic, brainstorm, compare options, and make a plan. In operating system language, this is the intent surface. Maya can explore the launch problem without pretending she already knows the final deliverable. She challenges assumptions, changes the audience, and tests a contrarian angle. Nothing has been shipped. No spreadsheet has been reconciled. No deck has been approved. But the problem has become legible. That distinction matters. Thinking is one layer. Producing reviewable work is another. The next door is labeled work. OpenAI describes ChatGPT Work as a way to delegate substantial tasks with a clear outcome, a brief, deck, analysis, recurring update, workflow, or file. Maya brings the goal, source material, and review criteria. The room brings a workbench, documents, spreadsheets, presentations, PDFs, research, and analysis. This is more than asking for a long answer. A deliverable has a structure, a file type, evidence, and a use after the conversation ends. The official guide also keeps the human visible. Maya can follow progress, answer questions, change direction, and approve important actions. Maya hands the system interview notes, a product spec, channel results, and a deadline. Work researches the supplied material, identifies contradictions, creates a concise brief, builds a spreadsheet of risks, and turns the argument into a presentation. Ari does not place finished files on a magic pedestal. He opens them in a review bay. Maya inspects the chart sequence, annotates the weakest slide, and rejects a claim with thin evidence. The output layer is most useful when its product can be examined. The system did not merely answer her. It produced artifacts that could survive contact with a team meeting. The floor splits. On the left, local work can use files and apps on the computer when those tools are available. On the right, cloud work can continue after the local app closes and can be continued from web or mobile. These are not interchangeable superpowers. A cloud task cannot automatically reach a folder or signed-in desktop session. A local task depends on the machine, permissions, and enabled tools. In enterprise and edu workspaces, capability also depends on policy and administration. The useful mental model is not the AI has everything. It is this task has this execution boundary. The corridor opens into a workshop of repositories, terminals, tests, and diffs. OpenAI's current product language gives Codex a specific job: understand and navigate codebases, build and test features, fix bugs, review changes, and prepare work to ship. That is different from producing a clever code snippet in chat. A codebase has history, conventions, dependencies, dirty files, failing checks, deployment rules, and consequences. Maya's launch depends on a broken sign-up path. Ari clips a bounded objective to the workbench: fix the verified bug, preserve unrelated work, run the checks, and stop before deployment. Codex maps the request flow, locates the validation error, edits the smallest owned surface, and runs the repository's real tests. One test fails. Instead of painting the indicator green, the system returns to the code, finds an edge case, and tries again. Maya reviews the diff beside the test evidence. Only then does the change reach a gate labeled external state. This is the production shift in miniature. Conversation becomes navigation, mutation, validation, and handoff. But the boundary remains explicit. Preparing a change is not the same as being authorized to merge, push, deploy, send, buy, or publish it. A chatbot reply has a natural stopping point. The message ends. Multi-step work needs a different clock. Official guidance for long-running work says to define an outcome, constraints, and completion criteria. Goal mode is documented in the ChatGPT desktop app, Codex CLI, and IDE extension, while hosted long-running work on the web uses ChatGPT Work. Maya writes a durable objective: reconcile the launch evidence, fix every attributable mismatch, and stop when the report passes its stated gates. Ari turns a large hourglass. The system can choose the next step, but only inside the problem Maya actually defined. The hourglass room has rails. The guidance recommends one clear target with a validation loop, not an open-ended instruction to improve everything forever. Related work stays in the same chat so context can accumulate. Independent work can use separate chats, but two tasks should not receive write access to the same connected source. That operational detail is easy to miss in a demo and essential in a real system. Persistence without scope becomes drift. Independence without ownership becomes collision. Maya marks the input boundary, the files and scope, the tests that count, and the condition that ends the run. Another room runs on clocks. Scheduled tasks can repeat in the background and can combine with skills. A desktop task may work with a local project in its directory or an isolated work tree, but the computer and app must remain running when local files are required. When scheduled is enabled for a workspace, web tasks can use uploaded context and connected tools, but cannot directly work in a folder on the computer. The CLI and IDE extension do not provide the scheduled management interface. Recurrence is real, but it belongs to a specific management surface and execution environment. At 7 each morning, Maya wants 3 things: today's calendar, important unread messages, and the decisions that need attention. A scheduled task returns to a saved prompt. A skill supplies the repeatable procedure. Enabled connected tools provide the authorized calendar and mail context. The result is a compact brief, not a raw data dump. Maya reviews it before anyone receives a message or a meeting changes. The magic is not that a timer exists. Ordinary software has had timers for decades. The shift is that recurrence, instructions, connected context, synthesis, and a reviewable result can live in one operating rhythm. The archive looks unified until Ari pulls apart 2 drawers. OpenAI's current documentation says ChatGPT Web uses ChatGPT memory, while local Codex clients use a separate local memory store and controls. ChatGPT Work uses the memory settings available to the account and workspace. It does not use the local Codex memory store. Memory can carry useful preferences and project context, but it is not the only place for rules that must always apply. Required team guidance belongs in checked-in instructions. Continuity helps the system remember. Durable documentation helps the team prove what it should remember. Behind glass sits computer history, an opt-in feature that turns activity across allowed apps and websites into a timeline and memories. On the research date, the official documentation limits it to the macOS desktop app for Pro, Business, and Enterprise. It is off by default. Business and enterprise administrators must grant access. It requires memories and is not currently available in the European Economic Area, Switzerland, or the United Kingdom. Users choose contributing apps and sites, can pause collection, and can inspect or delete history. This is a powerful continuity layer and a perfect example of why plan, platform, region, and consent cannot be footnotes. In the next room, shelves hold repeatable methods. OpenAI defines a skill as a reusable workflow with task-specific instructions and supporting resources such as templates, examples, schemas, brand guidance, or connected tools. A good skill does not merely tell the model to be excellent. It captures how a team actually prepares a daily brief, reviews documentation, creates a presentation, or applies a writing standard. Maya takes the launch review process out of one person's memory and installs it as a shared procedure. The result is not guaranteed correctness. It is a more consistent path to evidence the team can inspect. The switchboard is labeled plugins. Official documentation says a plugin is an installable bundle that can include skills, connectors, or both. Connectors are backed by Model Context Protocol servers and may include custom interface elements. In plain language, a plugin can bring procedure, connected capability, or the two together. But the bridge is not automatically open. Installation, authentication, workspace policy, requested scopes, and user approval define what can cross. Maya connects a project system for a launch brief. Ari shows the data line lighting up only after the authorized tool is enabled, not because the model guessed a password. The browser room gives ChatGPT a view of current websites and an interaction surface. The official guide says it is available in ChatGPT on the web and in the desktop app, but not in Codex CLI or the IDE extension. The built-in browser uses a profile separate from the regular browser by default. That separation is architectural, not cosmetic. A task may research public pages without inheriting every signed-in session. When an account is needed, the user signs into the task's browser context. Maya watches the shared window as the system compares options, then reviews the proposed action before any sensitive data is submitted. Browser interaction is still not the whole desktop. In supported regions, OpenAI documents computer use in the ChatGPT desktop app on macOS and Windows with ChatGPT Work and Codex, after the computer use plugin is installed. It can see and operate graphical interfaces for tasks where command line tools or structured integrations are not enough. On Windows, it uses a dedicated foreground session. On macOS, it can use the supported background experience. The capability is physical in a way text generation is not. The pointer moves, fields change, and system state can be affected. Maya gives a narrow instruction: gather approved launch details from 2 local apps, create a note, and draft a reply. Do not send it. Ari pins the allowed apps to the wall and leaves every other door dark. Permission prompts appear before access. The final screen shows the note, an unsent draft ready for review. OpenAI's own use case guidance makes the pattern explicit: scope task, permission prompts, reviewable result, and a pause before sending, buying, or changing anything important. The impressive part is that the computer can be used. The trustworthy part is that authority is constrained. This is the sentence most demos skip. A model capable of clicking a button is not automatically authorized to click it. A connector capable of reading a calendar is not automatically permitted to edit one. A coding agent capable of pushing a commit is not automatically allowed to publish production. The same action can be safe in one context and reckless in another. Maya can authorize a local draft and forbid an external send. She can allow reads and require review for writes. An operating system for work is not defined only by what it can do. It is defined by the boundary between possible and permitted. At last, Maya and Ari enter the chamber under the building. Permission modes control local actions such as editing files, running commands, and using the internet. OpenAI recommends ask for approval for most work. The agent can work inside the current workspace and pauses before crossing beyond it. Other modes exist, but enabling a mode does not silently select it or rewrite an existing chat. The setting is visible because the difference between convenience and control should never be hidden. Every task now has a capability map, an execution boundary, an approval policy, and a reviewer. Ari holds up 2 keys. Sandbox mode answers a technical question. What can the agent touch? Where can it write? And can it reach the network? Approval policy answers a governance question. When must it stop and ask a person? Official Codex security guidance describes these as separate layers. In the documented default local posture, the agent runs in an operating system-enforced sandbox, typically limited to the workspace, with network access off until policy allows it. A sandbox can prevent an action. An approval can authorize an action. Safe operation needs both the machine boundary and the human decision. Maya returns to the tested sign-up fix. The system can show the changed files, test results, and browser verification. Those are artifacts inside the review boundary. A push, deployment, email, purchase, publication, or permission change would alter external state. The control room raises a gate. Maya checks the evidence, confirms the target, and decides whether the next action is allowed. This sequence looks slower than a cinematic one-click agent. In practice, it is faster than recovering from the wrong repository, wrong channel, wrong customer, or wrong privacy setting. Good automation compresses work. It does not erase accountability. Ari rolls out the building plan. Chat turns ambiguity into intent. Work turns intent and source material into reviewable deliverables. Codex turns bounded software objectives into tested changes. Goals and cloud work add multi-step time. Scheduled tasks add recurrence. Memory carries selected continuity. Skills encode procedure. Plugins and connectors bring approved external capabilities. Browser and computer use provide action surfaces. Permissions, sandboxing, checkpoints, and review constrain the whole stack. No single layer creates the operating system feeling. The feeling appears when Maya can move a piece of work through several layers without rebuilding the context from zero. The building plan becomes a matrix. Columns read plan, account, workspace, platform, region, rollout, installed tool, and permission. Computer history is macOS only on specified plans and excluded in specified regions on the research date. Computer use requires the desktop app, a supported region, and an installed plugin. Browser does not live in Codex CLI or the IDE extension. Scheduled management lives on web and desktop, not CLI or IDE. Work may run locally or in the cloud with different reach. The honest product story is not one row of green checks. It is a map the user must inspect. Traditional operating systems translate human intent into controlled access to files, applications, networks, devices, and processes. This new layer does something analogous for knowledge work. It translates a natural language goal into plans, artifacts, code changes, tool calls, browser actions, and recurring workflows. It can carry context and select a procedure. Most importantly, it must arbitrate permissions. The metaphor works because orchestration has become the product. The model is the engine, but the user experiences the scheduler, the tools, the memory, the files, the action surfaces, and the gates around them. An operating system suggests stability, universality, and precise control. Generative systems are probabilistic. Tool availability changes. Interfaces move. Instructions can conflict. A model may misunderstand a goal, miss a constraint, or produce a polished artifact with a weak claim. Connected content can be untrusted. A permission prompt can become meaningless if the user cannot understand the consequence. This is why the system needs evidence, review, and reversible steps. Maya does not trust the launch deck because it appeared in a file. She trusts the parts she can trace to sources and the workflow that exposes uncertainty. The practical skill is no longer merely writing a clever prompt. Maya specifies 5 things. First, the outcome, what artifact or change should exist. Second, the context, which sources, files, and connected systems count. Third, the authority, what may be read, changed, sent, or published. Fourth, the evidence, which tests, citations, previews, or checks prove the result. Fifth, the stopping condition, when the task is complete or blocked. That specification works across chat, work, codex, goals, schedules, and tools because it describes the contract between a person and a system that can act. By sunset, Maya has a launch brief, a corrected spreadsheet, a reviewed deck, a tested code change, and a morning task ready to repeat. Ari places the permission keys back on the ring. The system handled more of the path from intention to output than the chat box ever could. Yet the most important moments were human. Choosing the goal, rejecting a weak claim, protecting unrelated work, defining authority, reviewing evidence, and deciding whether to cross into external state. The future of work may include capable digital coworkers. It still needs an accountable owner. So, is ChatGPT becoming an operating system for work? As a metaphor for the stack now visible in OpenAI's own documentation, yes. Chat is the thinking surface. Work makes deliverables. Codex builds software. Goals and schedules extend time. Memories add continuity. Skills and plugins add procedure and tools. Browser and computer use add ways to act. Permissions decide what action means. But availability is conditional, autonomy is bounded, and every serious workflow ends with proof and review. The most important feature is not the door that lets AI act. It is the gate that decides when it should.